In this video, we're going to go over some examples of rates and proportions. So let's start with this one. Your car can drive 300 miles on a tank of 15 gallons. Express this as a rate. Now, we've been talking about how a ratio compares to units. A rate is a type of ratio. And usually with a rate, we're going to take some value, let's say in units of measure. Let's call it unit A. So what I mean by that is like in miles or gallons or some kind of unit, and we're going to divide that by some other value, and it's going to be a different unit. When I say unit, again, I mean units of measure. So miles, gallons, feet, hours, those are units of measure. So we're dividing two values with different units. Now, if we do the miles on top divided by the gallons, our answer is going to come out in miles per gallon. Okay? If we take the gallon value and divide it by the number of miles, then we're going to come up with gallons per mile, how many gallons per mile we use. Now, certainly miles per gallon is more widely used than gallons per mile, but they both would tell you something, right? This would tell you, gallons per mile would tell you how many gallons it takes to drive 1 mile. All right. Now, for most vehicles, that's going to be less than a gallon, right? But maybe there's some kind of crazy tractor thing that, takes a gallon to go a mile or something, 2 gallons to go a mile. That would be pretty bad fuel efficiency. So in this case, I think miles per gallon is the way to go, right? So we've got 300 miles divided by 15 gallons. And you may be asking, do I have to write these words? Yes, you do. Always write the words. This is math literacy. Numbers don't really mean anything unless they have a unit of measure attached to them. So what's 300 divided by 15? That's 20. And then my unit of measure is here, as I said, miles per gallon. So the thing with a rate, this word per, super important. That's going to tell you to divide, and you would read it that way. All right. Let's look at another example. This is an example of a proportion. Now, this doesn't have any units of measure on it. This is just kind of a out of context equation. But in general, a proportion is either when a ratio equals a ratio or a rate equals a rate. And we'll see an example in context here in a minute. So you get a fraction equals another fraction, right? You're going to have like some number over some number equals some number over some number. That's a proportion. A proportion is an equation. A ratio is not an equation. It's a fraction. A rate is not an equation. It's a fraction. All right? When we have a ratio equals a ratio or a rate equals a rate, then we have a proportion. All right, so a couple different ways to solve this, and I'm sure this is something you've done in your past. One way is to do something called cross multiply. Now, I want to just motivate this a little bit. Let's say I have this equation A over B equals C over D. If I multiply both sides of this equation by BD, which is a legal algebraic move, and I cancel these B's and then I cancel these D's, what I end up with is A times D equals C times B or B times C, however you want to write it. So that's the cross multiplying. So what we're saying is you could take B times C and equal that to A times D. That's cross multiplying. It's not some magic trick. It comes from an algebraic property of multiplying both sides by the same number. So in this case, we know that 3 times x is equivalent to 5 times 6, which is 30. And we could have gotten that same result by multiplying both sides by 3 times 6, which is 18. The 3 cancels with the 18 to give 6. 6 times 5 is 30. The 6 cancels with the 18 to give 3. 3 times x is 3x. All right, so finish solving this. Pretty straightforward. Divide both sides by 3, and we get x equals 10. Okay, so what we're saying then is that 5 over 3 is equivalent to 10 over 6. Now this should make sense to you because if we double the top and the bottom of this fraction, we get an equivalent fraction. And that is another way that you can actually solve the proportion. It doesn't work for all proportions because they're not all as nice as this, but this is actually the easiest way. If you're looking at this proportion and you're saying, oh, look at that, the denominator doubled. Well, if this fraction is going to be equal, then the numerator is going to have to double. So this is times here. I'm using this x for times. So 5 times 2 is 10. So x has got to be 10. I mean, you don't have to go through all that fancy cross multiplying and all that for that one. You can just see what's happening there. All right, so if we were thinking about ratios, say we had a recipe that called for 5 cups of flour to 3 cups of sugar, 5 to 3. All right, and say we wanted to double that recipe, and we said, well, how many cups of flour would I need if I use 6 cups of sugar? Okay, and that's where we would get, this is a real life example of how we would get a proportion like that. 5 is to 3 as what is to 6? Well, you can just see we're doubling the recipe there. If it's not exactly double, it becomes a little more challenging, but you could use the cross multiplying then. All right, let's look at one more example here in this video. A map scale indicates that a ½ inch on the map corresponds with 3 real miles. How many miles apart are 2 cities that are 2 1/4 inches apart on the map? So I'd like to show you a couple different ways to think about this, and it's good to know both ways, okay? Don't just pick one, because certain types of problems lend themselves to different kinds of thinking. So let's just get an idea about what this is saying. So I'm going to do a ½ inch on this map. I'm going to say that's like from here to here. Okay, I'm going to call that a ½ inch. Let's get rid of this ruler. So that's a ½ inch. And so that corresponds to 3 real miles on the map, like whatever town this is. This is just some random map I found. So the question is, if it's 2 1/4 inches apart on the map, how many miles is that? All right, so let's pull this ruler down here, and let's say I want to go from here. So there's a ½ inch, 1 inch, 2 inches. Oh, this isn't a great ruler for a quarter. I think it's maybe right there. Okay, I wonder if it'll let me, like, nope, it won't let me do that till I get rid of the ruler. Okay, so we've got, from here to here is 2 1/4 inches. So what we really need to figure out is how many ½ inches are in 2/4. How many ½ inches? Like if I could put that ruler back, I could do this more accurately. But say there's a ½ inch and then 1 inch, and then 1 1/2. Oh, see, that's not good. That's too close together. Maybe I can put the ruler back in. So a ½ inch is about right there where that little river is. Okay. So a ½ inch is about right here. And then 1 inch, and then 1 1/2, and then 2, and then just a quarter. Okay, so we've got 1 ½ inch, 2 ½ inches, 3 ½ inches, 4 ½ inches, and then a half of a ½ inch. So we should have 4 1/2 of these ½ inches. Now that's nice when you have a visual. How would I do this mathematically? Well, what we're really doing is we're saying I'm going to take this 2 1/4 inches and I'm going to see how many ½ inches go into that. So 2 1/4 divided by a half. Now if you want to use your calculator, you can just change these to decimals. 2 1/4 divided by 0.5. If you want to do fractions, you can change your 2 1/4 to 9/4, change your divide to a times and flip it over. Remember that? And then multiply straight across, which is 18/4. So 4 goes into 18 4 times with 2 left over. And we get 4 1/2, which is exactly what we were visualizing using the ruler. Okay, so that means we've got 4 1/2 of these little increments, and every one of these increments is 3 miles. 3 miles, 3 miles, 3 miles, and then a half of 3 miles would be 1 1/2. So we want to take these 4 1/2 increments and multiply that by 3 miles for every increment. And we get 12, and then a half of 3 would be 1 1/2, so 13 1/2. So that's 13 1/2 miles. Now, that's kind of a logical way to work through it and think about it. And let me show you the proportion way. All right, so we could say 1/2 inch is to 3 miles as how many inches, and I'm putting the units of measure in here just for clarity, is to, oh no, wait, we know the inches, don't we? 2¼ inches. 2¼ inches is to how many miles? How many miles? Okay, so that's setting up a rate, inches per mile, inches per mile. You could also set it up, you could go 1/2 inch over 2¼ inches, that rate, and then 3 miles and x miles to solve for x and write a proportion. And then use your cross multiplying. Okay, notice the half and the x are across from each other in both of these proportions, and the 3 and the 2/4 are across, or 2¼ All right, so we're going to go 1/2 times x equals 3 times 2¼ Probably just, you could just use your calculator and go 3 times 2.25. So we get 6.75. We could change that to 0.5, 6.75. Divide both sides by 1/2, which is the same as multiplying both sides by 2. And we should get 13.5. Yeah, 13.5, right? Because that's what we got doing it the other way. So we should get 13.5 no matter which way we do it. So think about both of those ways, you know, spend some time after this video just kind of going back and thinking about both of those methods of solving this problem. And this is definitely a real life problem that we see a lot in scale drawings, you know, plans for a house, any maps, any kind of thing like that.